take a look at today is the new updated toolbox. So here's the new updated toolbox. The only difference is we've added one column here with identities due to symmetry. Okay, so everything else is the same as what you saw in the previous stuff, but now we're going to add one more piece. So reciprocal identities, we want to make sure that we understand sine and cosecant go together, cosine and secant go together, tangent, cotangent. The big one for the ratio identities, make sure you know that tangent is sine over cosine. Cotangent is flipped, so it's cosine over sine. And then we won't use this one too often, but the tangent is the secant over cosecant. Okay? You can derive that one if you don't remember it. Pythagorean theorem. Again, this piece is important, and it comes directly from the idea that any point on the coordinate plane is x comma y, which is cosine comma sine. And so we have a squared plus b squared equals c squared, which is why we get cosine squared plus sine squared will equal our 1 squared, or just 1. Okay? That's an important one. And then these ones are other manipulations of it, and we can kind of disguise these or transform them however we need to. The identities due to symmetry is the new piece today, and this also comes straight from the unit circle. We'll take a look at that here in a second. But the idea that if I go a negative angle instead of a positive angle, how does that actually turn out with a positive angle? What's its connection to it? So if we were to look at the unit circle, again, remember that x comma y is cosine comma sine. We know that we have symmetry two directions. One across the x-axis. We know that if I was to reflect across the x-axis, this would turn into positive cosine, comma, negative sine. So the negative sign just gets flip-flopped. Okay. And this is actually where that very first identity will come from. If I were to, instead of go a positive angle here, I went a negative angle. So sine of some negative angle, which they're going to call t, I'll use t, is going to be equal to, if I were to go negative, it's basically the exact same value, but negative of it. So this equals negative sine of t. Okay, so that's going to be the first identity due to symmetry that we're going to look at. The second piece is going to be, well, our cosine actually didn't change at all. So our cosine is actually cosine of a negative angle, whether I go positive or negative, is actually just the same thing. So this cosine value here is the same as that one. So going a positive or negative angle, they're going to be the exact same. So that's the second piece, second identity due to symmetry. And then the third one is going to be with tangent. And if we remember that tangent is sine over cosine, then we can think about a negative angle would then be a negative sine over a positive sine. So this actually behaves almost identical to the sine function, where tangent of a negative angle will end up being a negative tangent of its positive angle. Okay, so it behaves very similar to sine. Those are the three things that we'll see today, and it comes directly from that unit circle. So here's our new toolbox piece. Okay, so let's apply this. We'll do it to 4 different examples today. We'll start with problem 8, which is very similar to your 7 and 9. So if you want to follow along and do 7 and 9, but do them similarly, feel free to do so. The very first thing I will recommend you do on all of these, now that we have negative angles involved, is get rid of negative angles. So in this particular case, secant of negative x, we need to get rid of that. What is secant connected to? 1 over cosine. So we can think about that as a 1 over cosine of a negative x. And if we go back and look at our toolbox, cosine of negative x is the same as cosine of x. So we can actually just make that a positive. This is the same as just 1 over cosine. Okay? So when I go to write this, the next line can actually look like secant x plus 1 times the quantity secant x minus 1. Okay, so secant, because it's connected with cosine, will behave exactly like cosine. And so we know it just stays positive, and we can go to that line. Okay, then we'll use our distributive property twice, or FOIL if you were taught FOIL. Okay, and in this particular case, we end up with secant squared x minus secant plus secant, that difference of squares, so that inside piece will disappear, minus 1. And at this point, I'm like, man, I hope that looks a lot like tangent. So we can go back, we can look at our toolbox again here, and we see, oh yeah, there's secant, there's the 1, so let's subtract 1 from both sides. And sure enough, we end up with tangent squared equals secant squared minus 1. And so we can substitute this in as tangent squared. And then we have our identities. Okay. So in this particular case, we wanted to use the symmetry identities to get rid of the negative angle. Then we did our algebra stuff where we brought things together. We have a difference of squares, so we end up with that secant squared x minus 1. And then that becomes a manipulation of one of our Pythagorean identities. We'll substitute it. Okay? No? Where are we at? Which one?
How did you just change the secant x?
So the secant squared part, this one?
No,
or this
that.
one?
Yeah.
So this, I was able to say, so this part here comes from this. So I know that secant is 1 over cosine.
Yeah.
And then I know that cosine of a negative x is the same as just cosine x. And that is this part of our toolbox, which is a newer piece that we're doing today. And so I just substitute that in, and now 1 over cosine x is secant x. So then I use that to go back to that step. Now I have positive angles all over. So the next one we're going to take a look at, I think it's like number 12. Number 12 will look a lot like 13. So for these ones, now we have to, again, start by dealing with your negative angles. Start with dealing with these negative angles. So in this particular case, cosine of x is going to be just cosine x. That's symmetry. This is the same as its positive angle, so we end up with 1 plus cosine x on top. On the bottom, sine of a negative x, its symmetry is negative of its positive, which means we can substitute in a negative sine of its positive x. So there's our substitution set for both negative angles. I can recognize that this is minus a negative, so this actually can be plus a positive. And then we'll see that we have sine in both of our terms down below, so we can factor that out. So here comes our algebra stuff. So we end up with 1 plus cosine on top, all over sine times the quantity of 1 plus cosine. And now we see that our cosine, 1 plus cosines will cancel. So we're left with 1 over sine. And in this case, 1 over sine is cosecant. And now we've come to our final proof. That would make a little more sense? That would connect better? So, again, similar approach. We're going to try to get rid of the negative angles first. And then we'll do the algebra steps to hopefully start simplifying things. And then we'll do our substitution stuff. See if that moves at all. Okay. This one's actually pretty tricky. This one starts to get into a spot where you kind of get stuck. You have to think about what's on the other side to help us out. So our first approach is probably the idea of, well, let's just throw in sines and cosines and see what happens. So if I were to change the left side, we can say we've got sine x over cosine over sine. Okay, so now we're dividing by a fraction. Dividing by fractions are the same as multiplying by their reciprocals, so we can look at this as a sine x over 1 times sine x over cosine x. Okay, so all I'm doing here is I'm going to multiply by the reciprocal instead of doing that division step. So now up top we see that we have a sine x squared, or sine squared x, over cosine. Okay. And now I'm like, oh shoot, where do I go? I'm not really sure. I'm stuck at this point. There's nothing that's jumping out. Where do I go next? And as I look to the other side, what am I trying to make it look like? I see that secant involves cosine, and cosine obviously involves cosine. So how can I transform a sine squared into cosine? And so this is one of those parts where we start to see our Pythagorean identity, and we're like, okay, there's sine squared. How can I substitute this? So we can subtract cosine squared from both sides, and now we can substitute this in for 1 minus a cosine squared. And so now we're dealing with nothing but cosines. This is a common denominator. We can split into two fractions. So there's that part of it, which is 1 over cosine. One over cosine gives us secant, which is what we're hoping for. And then the other part, we have this negative cosine squared over cosine, so we're going to have a minus. That simplifies into just cosine. And so now we end up with our final answer of secant x minus cosine x. Okay. So this one starts to get a little bit trickier because now we're involving substitution where we're like, I didn't really know where to go with that, but we start to see the other side of our equation kind of helps us guess where to go next. Sometimes you're going to guess wrong, sometimes you get stuck, and then just try to backpedal, or even sometimes maybe try the other side of the equation. You can solve both sides. So if you get stuck, maybe try the other side and see if you can kind of meet somewhere in the middle. So you just don't want to shift things left and right across it, because then you're actually changing both identities. Last one we'll do today as an example will be, I think it's like number 30. And so here we're going to get into that idea of let's find common denominators. This happens a lot with identities. We have addition of uncommon denominators with fractions here. So if I were to do this, I can multiply this side by a sine squared over sine squared. We can multiply this side by cosine squared over cosine squared. And so we'll end up with sine squared plus cosine squared on top, all over a cosine squared sine squared on bottom. And then anybody see what the top looks a lot like? Looks like 1. Good. Okay, so this is just 1 over our cosine sine, and we're looking for exactly that. So we end up with secant squared and cosecant squared. So 1 over sine squared gives us cosecant squared. 1 over cosine gives us secant squared. Now we get to our final. Okay. How's that feeling? Stupid. Okay. It's kind of tricky, right? It's frustrating at points because you don't know where to start. Oftentimes the hardest part about doing these is how do I even start? So if you are stuck, my suggestion is guess. If you guess wrong, you'll find out pretty quickly because it gets really ugly. If you guess right, the rest of the problem usually seems pretty simple. Okay? So give it a guess. If it doesn't work,